Hello everyone. Today we will discuss again routing security, specifically BGP security. We will talk about information security, we can say. We will talk about origin validation, path validation, some RPKI, those kind of stuff. You might say, okay, Orhan, you did the video already for that. Actually, we discussed there mostly on the new drafts called ASPA, Autonomous System Provider Authorization, with the author of the draft. So I am expecting, as I told you, that draft hopefully to be a standard and then to see some implementation and deployment soon. Today, Melchior with me, we will talk about BGP security. It will be very informative and long discussion. There is another draft also, ASCON draft for the path validation, we can say. We will understand it, but of course, up to that point, ASCON draft, we will discuss some basics as well to cover the basics as well. But ASCON draft will be important for us to understand how another way we can use another way to solve the path validation issues. Then we will be able to compare ASCON and then ASPA, Autonomous System Provider Authorization, and then maybe Melchior can comment on that, and then we can maybe merge those kind of things. We will talk. Let's start. Melchior, welcome. Please, can you introduce yourself as well?
Yeah, sure. Hi. So my name is Melchior Aelmans. I work with Juniper Networks, and I am based in the Netherlands. And my role in Juniper is I'm a lead engineer cloud providers, which means that I work with our cloud provider customers, trying to help solve their technical challenges. And besides that, I have some hobbies. One of them is routing security. So I try to drive the adoption of routing security with customers. I try to convince the company that we need to implement proposals that come or RFCs that come out of ITF. And yeah, I wrote a small book about it, how to implement routing security. So yeah.
How can we find that book, by the way?
Oh, yeah, it's if you Google on day one routing security, it shows up on Google first or second link. It's a PDF.
Okay.
And basically it's the idea of day one book is that if you go through it, that within a day, maybe 2 days, you have implemented a certain technology or some methods. And in this case, the book describes sort of operational best practices for routing security. So it doesn't only focus on origin validation, but it also goes into what's an advice we give for max ASPA length, for example, or what is a BigNetwork filter, or what is a peer lock mechanism. So we try to
some best practices, etc. there as well.
Yeah. So the thing is, all the information was already available either on our website or on different websites, but there wasn't one place or one guide that if you would follow it from beginning to end, that sort of gives you all the tips and tricks. So we try to summarize those in a small book.
Yeah, definitely would be useful for the audience as well. By the way, those things, including other BGP stuff, in my BGP Zero Techno course, also we are covering there. Let me make an advertisement there. By the way, you are blogging and you are doing also podcasts. Can you mention, because for the audience, almost everyone, I think network engineers, so that's why they can benefit. Can you mention about that?
Yeah, sure. So we just started. I think we published 3 episodes now, and the name of the podcast is the Routing Table Podcast. And basically, the idea is that Rick Muir, you probably know Rick as well,
yeah,
and myself talk to folks in the industry. So the concept is we discuss a technology or indeed routing security, and we try to find the expert on that subject and have a conversation between 45, 60 minutes. And the audience we're targeting is engineers. So we try to cut through the marketing story and go deep down into the technology. So we've spoken with Tony Pricienda on Rift. Of course, we've spoken with Job Snijders on routing security. So yeah, it's check it out, I would say.
So Routing Table podcast with Melchior and Rick Moore, they are doing together. Guys, definitely I recommend you to check that one. Two great guys. So definitely I'm recommending. Also, you have a blog, I think. Can you mention about that one as well?
Yeah, I don't have a one site where I publish my blog. Most of the blogs are on LinkedIn.
Okay.
So I am a spokes for Juniper as well. So I tend to write some blogs for other websites, and but the ones I initiate are published on my LinkedIn page. So feel free to reach out and connect on LinkedIn as well if you're interested.
Okay. By the way, Jeff joined as well. I think everyone who follow us know Jeff Tantsura anymore. Jeff, welcome.
Hey guys. Glad to be here.
We were just introducing what we will talk and a couple introduction about us. Now let's start what we will talk.
Yeah, sure. So what I said, one of my sort of hobbies is routing security. So as we discussed during the preparations, the idea was to go a little bit into the current state of routing security. I think it's interesting to sort of do a basic introduction. Where are we now? What do we have? What is origin validation? And then, as you said, we can touch on ASCOMs.
Yeah.
But there's some other work as well, which could be interesting. For example, in RIPE, there is a proposal which basically asks RIPE to create AS0 ROAS for unallocated or unassigned space. So that could be an interesting subject to talk. And so I have some slides, we can go through them.
Definitely.
And,
I think IXPs also should do that, etc. So let's talk about that one as well. By the way, Jeff, if you remember, Alexander was saying there are a couple drafts, even other than ASPA for the path validation. So we will talk about that draft as well, one of them ASCOM. Melchior will mention about that. Yeah.
Yeah, great.
Okay.
So if we sort of look at the perfect world, this is a very simplified world where we have an internet with a user on the left side and a data center on the other side. Basically, if you, in the perfect world, if your innocent user tries to access a website on the IP address shown, then he should end up in the data center, because the data center announces the prefix in which this IP address falls. So this is basically how the whole internet works, right? So you have people advertising prefixes from a specific AS number, and you have folks on the other side trying to visit websites which are hosted on an IP address. And basically the why that works quite well is because we did a lot of tricks and adjustments to BGP, right? When BGP was invented, at least the version as we know it, BGP4, it sort of has all these mechanisms to prevent a lot of bad stuff. But when, let's say, the first versions of BGP became available, there wasn't a time where most folks knew each other, right? So basically we were all friends, and if you would, for example, tell me I'm advertising this network, then I would fully trust you, and you wouldn't dare to advertise me anything else, because I knew you personally, and so we could trust each other. And basically, once the internet started to grow and become become bigger and become more international, we sort of lost that personal contact. And so we started to invent mechanisms to sort of secure BGP. And up to a certain point, that works quite well, right? So most of the things I think mentioned on this slide are pretty familiar. And this is basically sort of the baseline what you should implement and should configure if you speak BGP and so if you're part of the internet.
Many things here, many things here, yes, very obvious. People probably would know, like filter long ASM paths, or IRR, we mentioned about that, probably we will again touch here, and bogons, etc. we mentioned, we will touch, but the peer lock and big networks filter may not be well known, so I think also we will talk about those, so people might scare if we say, you already know this stuff, so we will mention about those, don't worry.
Yeah, so we can go into those right now. So basically, what peerlock says is it's basically very strict filtering. So let's say you receive a certain set of prefixes from your customer, then it's very uncommon if you would receive those via a peer or a transit as well, right? So what you do by using filtering, you lock those. You basically lock the peer to that session. In other words,
what you are saying, if I receive
if your people homed, you would definitely receive it from somewhere else.
Yeah, I mean,
probably not your peers, but upstream for sure.
From your peers, still you would get, if you receive your customer prefix, that your customer might be multi-homed to your peer, and then they can send as well.
Yeah. But why would you? Okay, so there are of course exceptions, but in normal operations, you would use or you would want to send traffic to your customer through the peering, BGP session you have with your customer, right?
Of course.
Sure. So your own prefix would be preferred, but you would still receive them in control plane.
Yeah.
BGP, right?
In the control plane, you will still receive. Yeah. I think I call it, by the way, because as far as my research, I found a paper written by Gaur Rexford, and I call it Gaur Rexford model, which basically, if you receive prefix, let's say same prefix from your customer as well as peer and transit, it can happen in the control plane, and you would prefer towards the customer, because if customer use that one, you can charge more. Sure, that makes sense. That's why they generally implement with the local pref highest on that link, blah blah blah. So Gaur Rexford model, I call it. Maybe I'm wrong, but just based on my research, I found.
And that's why when your BGP is properly designed, you tag every route you receive. You know exactly what your customer or peer or whoever it is.
Definitely.
Yeah, of course, there's a difference between technical and operational reasons for doing stuff and commercial reasons for doing stuff. Let's say best operational practice would be, of course, if you receive a prefix from a customer via multiple sessions, so with your customer, with a peer, and with a transit, that you, of course, prefer the prefix you receive via the peering session with your customer, right? That would be, I think, technical and operational best practice. However, of course, there could be commercial reasons for doing stuff different, and there are even networks doing that as a business model.
Or customer just might ask you to do that. Don't prefer me. Send my traffic directly towards the peer session or transit by basically doing the community. Generally, in real life, it's done.
Yeah, of course. There are reasons to do stuff differently. Same goes basically for the BigNetwork Filter. What BigNetwork Filter basically says is that there are few big networks we can define, which are the tier 1 transit providers, but also Google, Facebook, Cloudflare, AWS, who are basically tier 1s, and you would call them big networks. And the idea between the big networks or the BigNetwork Filter basically says that you will never see those big networks via a peer. Because if you think about it, they sort of have a tier 1 status, right? So they will probably never buy transit from your tier 2 or tier 3 party you're peering with. So basically this filter, what it does is it filters out ASs or AS path containing the AS of a big network from your peers. Again, the exception here, of course, is if you peer with Google, Cloudflare, AWS, Facebook directly, then of course you should not apply that filter. But basically, it's not common for tier 1 networks or a tier 1 to buy transit from another tier 1 or tier 2 or tier 3. So if you would receive a AS path containing a tier 1 ASN via a tier 2, then probably that's a route leak.
So actually, we could probably say this way as well. If I see in the AS path 2 of those tier 1 anywhere in the AS path, right? 2 of them, it should be route leak. So
yeah,
only one time I can see in entire AS path those tier 1 ASN. If I see 2 times, so it should be route leak somewhere.
Yeah, where the difference, of course, is that tier 1s do peer with each other as well, because else you won't have full reachability, right? There's not one tier 1 covering all of the internet.
Definitely.
So you will always see some routes between or spread 2 routes over multiple tier 1 networks. But basically, what this filter is meant for is that you apply it on peering sessions with tier 2s and tier 3s and customers. Because probably, if you look at from a knowledge perspective, a lot of the knowledge, the bigger the network is, the more knowledge and the more skills you have in a lot of cases, right? I'm not generalizing, but in most cases, larger networks tend to have more engineers, right? So more knowledge. So a mistake made more often in smaller networks using less automation, for example, or having, let's say, a enterprise, right? A small enterprise where BGP routing or internet routing is not its core business. They tend to make mistakes sooner than a network that has everything automated and or has engineers who are focused on internet routing, right? So the idea here is not to filter tier 1s sessions with your transit providers or tier 1s, but to filter sessions with customers and peers. So that is what the BigNetworks filter does.
Yeah.
By the way, it's described in, I don't want to promote it too much, but it's described in the book as well.
No, you should, because I didn't know about that, and I would definitely want to have a look at that. BigNetwork filters, peer log, this stuff.
You should promote your book. It's a great book, and people really benefit from reading it. I really like reading it.
Which one? Which one? Which one, Jeff?
The one Melchior published on BGP.
That's why I'm saying, like, for example, Tony Pasanen. Jeff, you know his book, right? So even I promote it on LinkedIn as well. He said very good result after my promotion as well. And I am happy because I read that one. So he sent me, I reviewed. It was really good, and I can honestly, openly recommend to any of my followers. So that's why I did. I will have a look at this, and if Jeff says already good, that's good for me and enough for me. But I will have a look, because when I recommend, I will write what you will find in this book, what you will learn from this book. That's why I will check that one. I didn't know. If you don't mention, we cannot know. I mean, we can maybe, but it's now good time, because a couple thousand people at least in a couple days will watch this, and then they will get benefit as well, hopefully. Because, I mean, BGP security, this is real life, guys. So, and day by day we are seeing route leaks, hijacks, and all this stuff. some of them are very famous networks involving. That's why we know what's happening. But other than that, it's almost every day happening, and we are now talking about how to prevent those kind of things. That's why this is one of the most important sessions what we are doing. Okay.
By the way, the downside of the book is that it is written to be implemented on Juniper devices. So this is an invitation to you or whoever's interested to translate it to maybe Juniper, Arista, and different vendors' configurations as well.
I am, to be honest, I am not interested. I am not interested in the configuration.
You know.
Yeah.
The positive side, Junos CLI in general is very programmatic, very easy to read, and see it as pseudocode rather than CLI.
And not only that, from my side, I am not interested in the configuration, but I am sure there you are explaining the technology there as well. And you said some BCP current practices you are mentioning. So these are important for me. Other than that, if I will configure, I can find the syntax from Google. No problem. Yeah.
Okay. I think the rest of the concepts or mechanisms described here are sort of common. So if you don't have any additional questions on this one,
no. This slide is totally fine. Other than peer lock and big networks, now we talked about that, and let's move on. So, in the perfect world, everything is fine, right? So what we apart from IRR, which you discussed as well, let's summarize the problem as that IRR is not as complete or cannot be trusted to a level where it's sort of the truth. Unfortunately, one IRR database is maybe more reliable than another. Yes, we still have to use IRR currently, as there is maybe not yet a very viable alternative yet. So as you can see, the issue is that with the mechanisms we just described, that a prefix filter, for example, doesn't care about originating ASN or ASPA. Peer lock and mechanisms, peer lock and big networks filters are arbitrary. So what is a big network and what not? Filtering out small prefix announcements could be an issue for DDoS mitigation. So let's give some examples. For example, prefix filters don't care about the origin ASN. With the mechanisms which we will discuss, like RPKI, etc., we are of course filtering based on the origin AS. But prefix filters you cannot mention. We are speaking peer lock and big filters. We just Melchior explained. We are mentioning, okay, tier ones shouldn't be seen, 2 times in the ASPA, etc. But who are those tier ones? And then only if you are saying 15, I think around 15 of them we have, and then only those you are doing filtering. What else? We have 60,000 ASN in default free zone in IPv4 unicast. So for the others, what we will do? And filtering small prefix outbound is issue for the DDoS mitigation when we say, like /32, if you don't accept. But most of those DDoS prevention is based on those /32 announcements, so RTBH or flow spec 5575, etc. So basically, we are at the moment we are talking about those. If we give an example, okay, private ASN, yeah, for example.
Yeah, so there's another issue. Right? Let's say you have customers using private ASNs, then you cannot perform origin validation against the private ASN. Right, so there's the issue is that by now we have introduced so many mechanisms to filter specific things that it becomes quite complicated. That's, by the way, another issue to discuss another time. But the thing is that even with all these mechanisms in place, we're still not there yet. And I described IRR already. So let's quickly go back to our, let's say, innocent user who is still trying to use this website, which is hosted on the /24 prefix, which you see on the right side, originated from AS64496. And now we introduce a malicious actor, which starts to advertise a more specific of this prefix from a different AS number. And as you might know BGP a little bit, the problem now is that by nature, BGP prefers the more specific prefix, right? So when this innocent user now tries to access the website, all the traffic is attracted to our malicious user, right? And this is basically the problem we're trying to fix with RPKI origin validation, as it currently is.
By the way, for what malicious actor at the moment is doing, we call this action as sub-prefix hijack, because it's advertising more specific prefix than the actual owner. So we just as a name, we call it sub-prefix hijack. If it would advertise same prefix with the same mask, same length, /24, we would call it exact prefix hijack, just as an example, let me say. Okay.
Yeah, where this hijack is from a malicious actor perspective, in most cases more successful, as of course, because it's more specific, it attracts more traffic, right? So, so how are we gonna filter this or solve this issue? Because right now, all the traffic goes to a malicious actor, and he can, as you can see, now perform a man-in-the-middle attack. This is the example we've seen last year with my Ether wallet, for example, where a man-in-the-middle attack took place on the Route 53 name servers from Amazon. Right, this is the example.
I think around 80 plus something $1,000 was stolen, by the way. It was successful attack.
Yeah, there's a lot of discussion about the exact number in dollar values. I've heard between indeed a few $10,000 up to a few million US dollars. So I'm not sure what the number is, but the thing the malicious actor did wrong here was that the DNS servers he spoofed weren't answering for any other DNS requests. So pretty quickly, people found out that when they were trying to resolve a different website, that the DNS servers wouldn't answer for that request. So the hijack only lasted for 2 hours. So the damage was still sort of small. Could have been much bigger if they would have answered for different DNS requests as well, because then it would have been unnoticed for much longer. By the way, don't take this as advice to start hijacking DNS servers. So let's see how we can prevent it, right? So basically, what we want to do is, or what we should do is deploy origin validation using RPKI. And I know you went quite deep with Alexander already, so let's sort of take a step back from that and approach it from a, let's say, a first-time perspective.
Sure.
What RPKI is, it's a method of cryptographically signing records, and basically gets translated to, if I'm a resource owner, let's say my resources are a prefix and a AS number, I can cryptographically sign and make a statement that the prefix announced from my AS is also my intention. Right, so in other words, if you would receive my announcement, you can check that it was indeed my intention as the owner of the prefix that it was advertised from that AS number. And because we're using PKI, so the public key infrastructure, we can cryptographically sign that end-to-end. In other words, you can check the crypto part, and based on that, you can, with pretty much guarantee, assume that indeed the prefix announcement was what I had in mind.
Yeah.
So as IP addresses are handed out by the 5 different IRRs. They basically host a trust anchor, which is the root of your cryptographic validation tree. And basically in the database of the IRR, I, as the resource owner, create my statement. And that is different as with IRR, where basically you could, depending on the IRR, you could make a statement based on my resources, right? And as with the in RPKI, I am the only one who can make statements about my resources. So if you then ask the WER's database, hey, give me all the statements, you can assume or you can trust that the statement you have about my resources is what I've put in the database. And such a statement is called a ROA, which is a route origin authorization record. And that's basically consists of 3 things, which is the prefix with its length, the max prefix length. So it could say my prefix is a /22 and my max prefix length is a /24. And the originating AS is, let's say, AS10. So everything which falls in between the 22 and the 24, which comes from my AS, is what my intention was. And that is put in a so-called ROA. And so if you now want to start verifying these statements, you basically download, it's very simplified the way I explain it now, but basically you download the database with the ROAs to a validator, which is a VM you run in your network. And the validator does all the crypto stuff for you. So it checks all these cryptographical stuff and basically sends a database to your router. And your router, when it now receives a BGP announcement, it checks against that database if those announcements are indeed in line with my intentions.
Yeah, yeah. So with those checking against the databases, we call it route origin validation. So one side is doing authorization, and then all the other people should do what? Validation. Whether, okay, I got the announcement now, maybe attacker is saying, I am the owner, but I know the truth is coming from those RIRs, regional internet registries. So they sign it cryptographically, it's signed. I am believing them, and based on those we have 3 states. I think we will mention about those, valid, invalid, unknown, those states we will mention. So, and we can take some action based on those states, based on those status.
Yeah. So if you would put that in a very simple drawing, you just basically explained it already. So on the left side there's the RIR's database. As I live in the Netherlands, my IRR would be RIPE. So in RIPE's database, I put a statement for my prefix that I'm announcing it from my ASN. That is put into a cryptographically signed ROA. Those are sent to indeed a piece of software which is called a validator. There's different implementations of validators. Basically, they all do the same. So they download the ROAs from the 5 different IRRs. They do the cryptographical check.
I think, Melchior, can they also download it from ARIN, or there's a still problem?
That's a good point. So most IRRs, except ARIN, they publish the file without having to do any additional stuff. So if you install the validator, it automatically downloads the tool file. However, except for ARIN, who requires you, but I think they're now changing that.
Hopefully.
You have to sign a legal waiver and stuff like that. It's probably typical American. But yeah, so there is an extra step involved to get the ARIN tool in your validator as well. That's correct. Yeah. But yeah, so as I said, simplified, it sort of looks like this. So now if we go back to our router, we received our malicious route advertisement, right, which is the /25, the more specific of the /24 we should have installed and used. But now we have a router connected to our validator, and the validator sent us a database with an entry telling us that this prefix we've received should have had netmask of 24. It's already very late in the Netherlands. So now my router can check this route advertisement I'm receiving against a database, and because it noticed that it isn't a 24 but a 25, it is a invalid, as you just mentioned, advertisement. So now I can start building a policy, an import policy on which I use for my transit or peer, and basically state if I receive a route announcement which is invalid when it's checked against that database, then I want to reject it. And so in other words, I won't install the /25, but I will keep on using or install the valid announcement, which is a /24.
This one big debate, I think. We also discussed this, but somehow it was not quite clear with the Alexander discussion as well. So this invalid state, when I see that, okay, /24, /25 malicious actor was announcing, and it is basically not correct because max length I was defining as /24. Now, if this is invalid, many people says, let's reject invalid, though they cannot even themselves, they cannot reject. Let's talk about this, invalid reject, or when it's invalid, reducing the local pref. So let's talk about this, pros and cons, etc.
Yeah, interesting one. So even on the Juniper website, until very recently, the documentation showed that you should lower the preference on an invalid. I had that changed to invalid is reject. Why? Because let's take this example. If I receive I receive a /25, which is invalid, and I lower the preference, and I still install the /25, then what happens?
Just a second. You cannot install /25 because that /25 not only, I mean, longer subnet mask, but it's not sending with any crypto.
No, okay, but let's.
I mean, in the cryptographic message, I see that not only max length, but also ASN owner should be 6446. Okay. But the other guys is saying I am totally different ASN, so they are not doing even those path shortening attack, etc. So I am connected to owner. So this guy is saying, attacker is saying, I am different ASN, I am the owner, but this is not verified. That's why even if they are sending /25, it will not be accepted anyway.
No, true. In this case, the validation fails on two things, right? So one is that the subnet link is incorrect, and the other thing is that the originating ASN is incorrect. Let's say I would spoof the origin ASN, and so I'm advertising a /25 and a 24. However, the ROA says it should be a 24, right? So I receive a 24 and a 25 from the same ASN. Which one should I install?
Of course, I should install the valid one. I mean, /24 one.
But by default, so in case of validation, the correct one is the 24, right? And the max prefix length is set to 24 as well. So in that case, the 25 is incorrect or invalid based on origin validation, right? So and then there's the question indeed, do I reject the invalid announcement or do I set a lower pref?
What you are saying, if you are accepting /25 and you would use it because even if you lower the local pref, longer pref will be okay. Fine, now got the point.
And there's a number of beautiful commercial tools like Nocturne who will go and happily disaggregate your prefix.
Good. Okay.
So I see why at the beginning the advice was to set a lower pref, because the problem is, and especially for networks that sell transit, is that the more routes you can advertise to your customers, the better connectivity you can provide them, right? And so the more money you can make. So it's very hard for networks, and maybe it's in our nature as well, because we were all grown up when we were configuring networks, that we needed a full routing table, right? If you don't have a full routing table, you cannot reach every destination on the internet. So now we're saying you have to reject announcements and so not have a full routing table. So when we started with RPKI, the advice indeed was then to lower the preference. So you would still sort of have a backup in case the route was there was no covering route, less specific, etc. However, operationally seen, indeed what we were just saying, the route is then still used because it's more specific.
Yeah.
We now started to realize that for the majority of more specifics, there is a less specific covering route, right? There is, let's say, of the 5,000 invalid routes, for the most part, there are less specific covering routes. So if you filter out those more specifics, there is always another covering route.
And practically, there's a number of interesting white papers, actually, one by Microsoft, one by Volta Networks, I believe, where they use algorithm to compress your routing tables from what is today 800,000 routes to something below 100K. So you could actually accept it on Broadcom Trident 2 like switch. So you can definitely remove more specific, use for traffic engineering if you do it right, and you can algorithmically validate that you're not losing connectivity.
So are you talking about this? There was, I think, suppression one. Okay,
no,
so
compression.
Compression one. So there are a couple things actually there. Go ahead, man.
So what Jeff is saying, is that the majority of routes advertised on the internet are more specifics of a less specific, which is advertised as well. So if you have like merchant silicon, or let's say you have reduced FIP size, you cannot have the full routing table in FIP. Then there's a few things you can do in order to sort of shrink the full routing table. So one thing.
But this would be a problem but I see even problems with that. Let's say customer dual home to 2 operators, and then getting PA space, provider aggregatable space. So then let's say /24/23 to that operator, its own operator is advertising to the default free zone. Then /24 another dual home operator, another operator. Now I see 2 route for that network, stub network. Now if I would just use the aggregate /23, I would always go to that the operator, which is the owner operator, let's say transit 1. Then I will break those people's traffic engineering ideas, right? With this.
Yeah, so you choose your poison. You either ignore traffic engineering or you blow up your TCAM table.
Excellent. Okay, cool. I catch the trade-off there. Okay. Yeah.
Yeah, there is of course a MET, for example, as well, right? Who doesn't filter out MET?
Yeah.
Right? Basically, everybody filters out MET. So the purpose of traffic engineering in the global internet or the global routing table, it sort of works, but I think going forward that we will see more of these filtering mechanisms and people starting to, let's say, introduce tricks to reduce the, at least the routing table they have to install in forewarning. But in contraplane, it's easy. You can add more memory and you can have a larger table, but in silicon, it's a bit harder.
Practically, I mean, the survival of tier ones or transit as such is very questionable with all the traffic going to Google and Amazon, right? So, but companies have good engineering teams, have introduced community-based traffic engineering ages ago. So they tell you exactly how to tag a route to take a particular decision, right?
Yeah, but I think this could be a subject for a whole discussion as well on itself. But it's definitely interesting. So let's discuss that another time further.
Okay.
So clear on the why not lowering pref, right?
Yeah.
I think we're
rejecting invalid is good, but still, not everyone can easily do that, especially transit ones. Yeah.
Exactly, and so we also saw what the issue is with origin validation as we currently know it, right? So we can validate if the prefix is indeed advertised from the correct AS. However, if, as we just quickly touched on as well, if I would also spoof the AS, the ASN, then I'm basically verifying a valid route advertisement, right? So in this case, again, our innocent user is trying to reach something in our /24, indeed in this case originating also from AS64496, but now our malicious actor starts advertising the same /24 from the same AS number.
This one is very critical for the all audience at the moment. Give your attention here, because the rest of the topics, if you don't understand this one, will be harder for you. At the moment, the malicious actor is advertising with the same ASN, with the real owner ASN, and even same subnet mask. So what will happen? Until the rest of the discussion of this video will be based on this understanding. Very important.
Yeah, so in this case, part of the traffic will still probably still go to the to our data center, but part of the traffic will also end up at our malicious actor, because in this case there's no more specific. So the route is the same. So in BGP decision process, we have two 24s, and there's a whole structure on what we base the decision on which route to install in forward, right? So part of the routers forming the internet will now install the correct route, and parts will install our malicious actors route.
Depends on the proximity. Whoever is closer from the ASPA length point of view to data center, they will come there.
Whoever any casting the prefix.
Yeah, actually any casting, exactly.
In this case, the shortest AS path will win. Yeah. Right, because that's the next decision factor for BGP. So here it is. Shortest AS path, the route with the shortest AS path will be installed even if we would perform origin validation, because the route is valid now, right? It has the right prefix length, it is the right prefix, and it comes from the originating ASN as stated in our ROA. So in this case, our malicious actor will win if he has the shortest AS path. So here's where you can partially solve this problem by peering as much as possible on internet exchanges, for example, right? Because by peering with other networks on internet exchanges shortens the AS path. So in this case, if our innocent user's ISP would have a direct connection peering with the data center, then the AS path is one extra AS. And it's very hard for a malicious actor to, in this case, then have a shorter AS path.
To win,
so the shorter your AS path are, the less you will be impacted by this attack.
And
this goes back to prepending.
Yes.
And you should really think about how many times you prepend, if at all, and how much leverage you get by prepending.
And prepending, or also you can find an article on that, Orhan Ergun ASPA prepending problems, etc. So if you prepend as many times as you want, so there will be other problems, not only being a bad citizenship in the internet, because when you prepend more, it will even consume more device resources. But other than that, you are also doing something against your BGP security, because now, as you can see, attacker can win. Also, day by day, we are seeing more and more connection, direct peering. So one-hop neighborship we are talking. And this concept is also, many people say, I think Jeff Houston also was saying, flat internet model. So just as a terminology-wise, that's okay. Say that. Flat internet.
So, how do we solve this? That's then obviously the next question. BGP Sec, right? It's already there. So it's defined. It's a nice RFC. However, the issue with BGP Sec is that it does work on small scale. However, if you would want to start doing crypto between every router on the internet, then you blow up your control plane, basically, right? So, because cryptographical stuff is pretty intense for CPUs, so I don't really see BGP-SEC being deployed on large scale. Also, because it hasn't been done yet. If this would have been the solution, then it would have been wider deployed than it currently is. So
yeah, and as we could see, it's not only hardware limitation, because you take any modern router, something like MX or ISR9K, it has 4 cores Intel running really. It's a decent CPU. It's more operational issue than hardware, I would say today.
Yeah, true. Yeah.
Why you said that? Why what you mean operational issue, Jeff? Can you talk about that?
Yeah. So if we look at hardware resources, modern Intel CPU has hardware offload for crypto. It can actually do it, but deployment and the fact that there's no critical mass. So it's just you and few other guys doing the GP set, right? There's no real critical mass to deploy the feature.
As long as full deployment, full adoption, so partial deployment will not basically solve the path validation issue with BGP-SEC, that's okay. Okay, got your point.
Same basically goes for SOBGP, right? But you discussed it with Alexander as well, I heard, so we won't go.
My question to you guys, both of you, you are very active in ITF, of course. So this is my question. It's very obvious for many people, this crypto part, this wouldn't scale. Let's say, but my point is not that. Partial deployment has been an issue. I mean, IPv6 was there, and we've seen that we should give people some, immediate benefit, and we shouldn't expect, one-time approach, and okay, you will even switch off this one and then enable another one. So this doesn't work.
No, let me give you a very simple example.
This doesn't work.
MD5, highly insecure, breakable. I think in ATF, we started to advise people not to use MD5 before a lot of people were born, right? Look at who, if you have passwords at all, look at how many people don't use MD5. Everybody does.
Yeah.
It's not a priority.
I mean, exactly. It's not people priority. That's why IPv6 is not priority. They are easily finding IPv4 address transfer, all those stuff, CGM, blah, blah, blah. Same thing here, BGP-SEC. This is not my first priority, really, from the operator point of view when I think about it. Okay, someone else. Always I can throw the problem to people. Okay, let them solve, let them solve. And this was obvious. And then requires a lot of device resources. Let's accept that one as well. Not everyone has ASR 9Ks, Jeff. So from this aspect, I mean, why even became an RFC then? Why lots of effort? People spend a lot of time on it. I mean, I didn't get this. Why?
There are people doing theoretical work. There are people deploying network. Sometimes there's a difficult gap between those two, right?
Okay.
A lot of the work done in IETF is more a study or people who just want to have their name on an RFC and a lot work being done in IETF is indeed more scientific or research than that it's practical. On the other hand, coming back to MD5, there is an alternative for MD5, which is TCP/AO, which is written, I think, by now 10 years ago. And finally, we now start seeing vendors actually writing the code to support it. So I think I know that Cisco has production code for TCP/AO. Nokia is almost that far, and Juniper is working on it as well. So there will be an alternative for MD5.
There's a slide at the end of the tunnel, yes.
Sorry?
There's a slide at the end of the tunnel.
Yeah. But so the thing is with adoption of doing stuff differently is that there's a lot of things you need to take into account. For example, the reason why IPv6 wasn't really taking off is at first backwards compatibility, right? It should have been backwards compatible with IPv4. The second thing is that there was no business driver for IPv6, right? And even now with IPv4 runout, IPv4 is still too cheap, basically.
I mean,
it's not expensive enough.
You can extend the life of it with the many ways. Let's accept
not
that.
So good for you.
Exactly. And the interesting thing now is why I think new stuff like SRv6, SRM6, and Rift are so interesting is because they finally bring solid use cases for IPv6. So now that we start seeing, for example, in large-scale data centers, using BGP as underlay is sort of scalable until you run out of
ASN.
Private ASNs, or if your setup is that large scale that you run into issues with your IPv4 numbering plan. That is where IPv6 in combination with Rift can solve a lot of practical problems.
By the way, for those who wonder what is Rift routing in FAT-trees, we had a couple videos, I think, also with the author of Rift, Tony P. Jeff was there as well, so you can watch it. Rift, what Melchior is saying, is very important. Okay. Sorry for interruption, by the way. Just yes. I wanted to add this.
No problem. No, so there's multiple angles why the technology is not adopted, or it takes 10 years to become adopted. Okay. But yeah, it's interesting, and sometimes it's the other way around as well. Good ideas don't make it in IETF and either become proprietary or won't ever see the day of light. So. But yeah, that's about BGP-Sec.
Yeah, I mean, it is really only RFC at the moment for path validation. RFC. There are drafts. We will talk. So far, we talked in the previous video. Now we will talk another one as well. And the good thing is we will be able to compare. Now BGP-Sec already there. Now ASPA we know what it is. ASCOM we understand. Overall, we will be comparing.
Yeah, so I won't go too much into ASPA as you have 2 hours on ASPA already.
Yeah.
So let's quickly look at AS cones, which is another way of addressing the AS path validation issue, where basically, in very short, ASPA sort of describes a mechanism for the resource owner to say these upstream ASs are allowed to advertise my AS. AS cones tries to address the issue from the angle of the service provider. So basically, what AS cones describes is a mechanism where you as a service provider can add ASs, downstream ASs to your cone. So basically you're saying, I will advertise these downstream ASs further upstream. The reason for doing that is because a lot of the, let's say, tier 3 networks are basically stop networks. So the idea is that the service, the tier 3 AS, so the stop AS, doesn't have to do anything. The service provider will add your AS to his AS cone and basically tells his peers, these are my downstream ASs.
I mean, but from ASPA point of view also, when customer does this, other than tier 1s, everyone is customer anyway, right? Let's think about from that aspect. Other than tier 1s, everybody is paying to upstream anyway. Yeah, they might have still customers. They might have, of course, their peers, but they will have their upstream as well if you are not tier 1, and we are talking 15 companies there. When we say Google, okay, large network maybe, second biggest carrier it would be Google, but at the end, they have more than 10 transit ASN also. So they are not tier 1 service provider. And when we think about from that aspect, I mean, still ASPA is solving a lot of stuff there. Maybe when we say stop network don't need to do anything with this, but I am thinking also service providers there in the ASPA is customer, so they will still do. But starting to understand this, ASCON is doing from one level above. So provider is doing who are my customers, ASNs, and also who are my customers of customers. So hierarchical way, right? So they are advertising those, and then, but I want to understand this. Just ASN or what you are thinking? Prefix belongs to this ASN.
There are two parts. There's policy and the object itself, right? I'll
please, Melchior, please.
No, so correct. So what ASCONS tries to do is it maybe it tries to be a little bit simpler from that perspective, from the perspective of the downstream AS, from the amount of work that needs to be done. On the other hand, it sort of is a way to tries to do RPSL and create more feature parity, as it says here, between IR and RPKI. So basically, the way you describe it with the AS cones object and the policy object is that you can describe the relations as you would do in IRR. And hence the last goal is to be IRR, but without the independence of the current IRRs. And where, of course, you try to, as with origin validation, come to as close as possible as what the intention really is, right? Instead of someone else explaining your intentions, where the idea is that you put in your own intentions. So again, as what I said, the biggest difference maybe is that the original idea was that stop networks don't need to do anything and make it as simple as possible. What we're seeing with origin validation as well is that creating the ROA, although it's, especially in RIPE, it's really simple to create your ROA, it is still a action a network needs to undertake, right? And again, going back to are small enterprise who has one router connected to in transit and who doesn't have a full-time BGP internet engineer or architect, for him or her, it's an extra step to take, right? And I think the problem in a lot of cases with whatever security is that it's too complex, right? People try to circumvent security because it sits in their way, it's complex, and so if we want to convince, especially folks who are not 24/7 working on public routing or BGP, it should be simple for them. So if we look at simplify or how it works, a AS set, it basically describes the relation, right? So it describes which ASs which customer ASs will be behind my AS. And so, by the way, I copy-pasted these slides just before we started. So I see now that one of the statements is not true anymore. It says work is being done to prepare a draft. The draft is actually there. I'm very recently have been added as an author to the draft, so I'm still sort of seeing and figuring out for myself. However, we got quite a lot of feedback already, and part of the feedback was that because the service provider adds its customers to his AS cone, it isn't exactly the same as within origin validation, right? When we said you create a statement about your routing decisions yourself, in AS cones it would be the service provider sort of making statements.
Okay. So, now, what so far, from my understanding, what's the difference from the IRR then? Because we are also creating a set object there. Okay, fine, it might be so many problems there, but what's the difference?
Well, so that was sort of my feedback as well, where I said I want the customer to acknowledge that he's being added to the AS cone. That made me an author. So, so giving feedback isn't. Oh no, I'm just kidding. Now, so the part of how to become an author on a draft is true. If you have enough feedback, then at one point they will say, okay, you have so much feedback and suggestions, you should join as an author. But yeah, totally agree. So that was the reason why we now described that the resource owner has to acknowledge being added to a cone. Because else it's not.
Then you are expecting still some work to be done by the stop network.
True, yeah, but there's no way to work around that. Or if you have any suggestion to work around that, then please let me know. But,
no, because otherwise, if this is true, but there might be other validation, maybe I need to think about for sure. But otherwise, you would end up with being IRR ASet object, so operational state versus intended state issue. So I got your point, totally fine. And in fact, with this, but you can, of course, that validation might be very, very easy. So they wouldn't need to have experienced network engineer probably to do that. Let's be honest. I mean, still, even if you want to create today your ROAS on, even on RIPE, the very simple you say, but network engineer should be there. In fact, the network engineer who understands at least some BGP needs to be there, and BGP is not that trivial protocol. Let's be honest on that. So it's not like just static routing or default route, etc. So you should be confident. And then maybe with ASCON, what you are expecting from the stop network engineering side, probably even system engineer could do that. But then question is this, Melchior. Where will be this ASCON creation process? Will be on the regional interregistries, RIRs, or how it will be done?
Yeah, so we basically leverage the RPKI infrastructure, right? So the ASCON is a object, as is a ROA, right? Where the ROA describes the relation between the AS and its prefix. An ASCON describes relations between AS numbers. And so from that perspective, it's comparable to ASPA, which does the same thing, right? It leverages the current RPKI infrastructure.
Okay, question immediately comes, another problem. I mean, I see as a problem, but you might maybe think already and addressed. So let's see. Today, if attacker is advertising a prefix, that attacker anyway signed some paper probably, right, with the upstream provider. So commercial agreement there, but still attacker is doing a lot of bad things, like maybe advertising someone else's prefixes, hijacking, or maybe they are advertising some unallocated blogs for spamming, blah blah blah. So, but still there is a commercial agreement, and service provider maybe not creating some objects, but still they accept those prefixes. And when you just create this ASCON object and say to the database, let's say 5 RIRs are doing this, and then I mean same issue. I am saying, okay, this guy is authorized to advertise. This guy is my customer, authorized. How you will prevent?
The difference is that you create the ASCON in the LIR's portal, as you would do with the ROA, right? So the only one who can create an ASCON for my AS is me, because I'm the resource owner. So in case you have a downstream customer that only has one AS and is not providing transit to different ASs, you can add the AS to your ASCON, right? Because then that relationship is pretty clear, right? But in let's say my downstream customer is providing transit to another downstream for him, then you have to create an ASCON. And the only one who can create an ASCON is the owner of that ASN. So you create the ASN or the ASCON just as you would create a ROA.
No, for me, still not clear, because just a second. I am the, let's say, tier 2 operators. Okay, I am tier 2, and then I have some tier 1, tier 3 customers. And now I am creating ASCON object, and I am saying, these ASNs are my customers, and then advertise everywhere. Now people are doing ASCON verification, and they say that, okay, Orhan is saying these ASNs are his customers. And now one of my customers is advertising some prefixes which they don't own, belong to someone else. But if my ASCON is valid, because this is my customer, how verification will basically prevent this? Because this guy, still my customer is, there will be also ROA there, you are saying. So not only ASCON, in this case, basically route origin validation will solve this issue. Okay, ASCON in this case is,
yeah, ASCONs does not replace origin validation.
Cool. Yeah.
It sits next to origin validation. So origin validation checks the originating ASN if that ASN is allowed to advertise the prefixes, and ASCONs and ASPA check the AS path.
Remember Alexander's presentation, you needed both.
You needed both. Here also you need both. So RPKI as well as ASCON. Okay. One is doing from the customer side, another is looking the problem from the provider side, upstream side.
Yeah, so both have a right to exist as well from that perspective, right? So they could even, you mentioned briefly, maybe the two drafts should join. By the way, I think that could be an interesting concept. But if not, then both concepts can even exist next to each other, because they both sort of come to the same purpose, but from different angles.
And by the way, ASCON also suffer from the same issue, it seems. Like if provider is doing something wrong. I mean, provider is your provider. I mean, provider who creates ASCON is the attacker, then there will be a problem. If that guy is the attacker,
yeah, but that basically goes for origin validation as well. If you don't create your ROAS correctly, or if you're in a migration, you forget to update your ROAS, then you have issues, right? So yes, and the thing is that the problem is with BGP, as we said in the beginning as well, that we're adding more and more bandages to it, all right, to fix issues we're experiencing along the road or along the way. And this is another basically bandage, right? In an ideal world, you would probably do it all differently, but the thing is we cannot abandon BGP. Right, so we have to work with what we have, and it has to be backwards compatible, and we can probably for another few years not rule out human interactions as well.
Okay, for just a second. Another question. It's almost like SOBGP, this one. Why? Because with the SOBGP also, I mean, I am saying this guy is my neighbor, and you are saying, okay, Orhan is my neighbor, then we get some score, right? Trustable or untrustable, etc. If we are not saying both of we are the neighbors. So in this case, I am saying, okay, these guys are my ASN, then the customer is verifying, yes, that's saying truth. How this is different than, okay, difference is you are creating this object in the RPKI environment, and it's cryptographically signed, and the trust anchor is there, etc. Okay. But otherwise, a little bit similar to SOBGP as well.
Yeah, I don't know all the specifics of SOBGP from top of my head, but I agree that the principle is the same. However, SOBGP, as far as I'm aware, has the same downside as BGP Sec, that it leverages the router to take care of the cryptographical part. And that is what we don't per se want to. So in this case, with ASCONs and ASPA, all the crypto takes place on the validator. And basically, again, as with origin validation, the validator just sends database from the validator to the router.
And if, let's say, ASCON status is invalid, I can still do the same operation like RPKI, right? It's invalid, I can reject, or I can reduce to local pref.
Yeah, so you've got data, you've got policies that decide what do you do with the data.
Yeah, so basically we describe in the draft a few scenarios, right? So a few modes of operation, if you want to say. There's loose mode, which is sort of the thing you do with origin validation if the state of the announcement is unknown, right? So you don't know it for sure, you've checked it, but there's no object, so you just trust it, or at least you just use it. In total there's 4 stages, and the most strict one is, of course, that if there's a single AS or path within the announcement, which is not covered by a relation described in ASCON, then you don't use it.
Actually,
and
what
of course, a few...
Sorry, go ahead, please.
No, and there's a few options in the middle. So you take out only what is downstream from a not verified AS, or you take out the whole tree.
Yeah, and what probably can be done, maybe some people also thought about that. Now, both of these approaches, right, ASPA and ASCON for the path validation, is also, I mean, proposing for the origin validation to use RPKI. Fine. Now, if this is the case, you and from Alexander also talk what we talked there. For the ASPA, we don't need to have extra validator. On the same validator, we can validate the state of ROAS as well as ASPA object. Now, probably ASCON object as well, if that's the case. Now, maybe this kind of policy could be created. If RPKI status invalid as well as ASCON status is invalid, definitely reject. If RPKI is invalid but ASCON valid or vice versa, okay, then reduce to local pref, etc. Because now you have two entropy and you can have other type of policies as well. Or strict policy, yeah, if both of them is invalid, this should be rejected, man. You will be very safe if you would reject, etc. I think, it would be maybe nice. By the way, I am...
You want it in logical or logical end.
Exactly. By the way, Jeff, as you can see, I am giving lots of feedback. I should be out there as well.
There's an acknowledgement session as well for people who have too much feedback. So they get an acknowledgement. I'll think about
Guys,
it.
good stuff is here happening. Good stuff is happening, really. I think both are coming from, totally different aspect. One is from customer side. And this is what I see from generally, like if I would give an analogy, we are BGP guys. So if I would give an analogy like AdPath versus diverse path, shadow RR issue. So either you will do everywhere or, lots of jobs doing with the maybe ASPA, it seems, because you are expecting to be created those objects from everyone. Here, probably simple verification by everyone, then creating ROA by upstreams. So yeah, that's why you were saying maybe the idea could be merged and then come up with something very strong. Yeah, cool.
I think it's worth exploring. It's harder to convince authors, but that's a different thing.
No, but at least we are moving. At least we are not stuck in BGP sec and then okay, we cannot solve this issue, man. So with the RPKI plus, if one of this stuff comes together, RPKI plus path validation, we will be solving 80-90%. I think there was statistics also based on all known attack types. One lady from one university, she was doing 88% or something, I remember. The most known attacks types are prevented if, for example, BGP sec would be successful, let's say fully deployed, and then RPKI fully deployed. Still, there are some type of corner cases cannot be addressed, but 88-90% is good amount of security on the okay.
Sure. Yeah.
So in general, there are like two ways to create a standard in ATF. One is scientific. So you are trying to solve scientific problem. You might do so. So security BGP is a very good example, right? Vendors are not going to do it because there's no ask for customers, and customers are not going to do it because there's no implementation. So you've got a bunch of RFCs that do that. You've got a number of RFCs that are pushed by vendors. So they see value in particular technology, often patented, often given them some edge. Eventually, they push it to some customers who don't really know what's good for them. So again, partial adoption. The best way is when you're actually the user. So look at Job, for example. Job Snyder from NTT. He is using this stuff. He is pushing the standard. He is beating up his standard. This is how you really get stuff implemented.
I know,
So
I remember, you are right. I remember Job came out with a couple RFCs like 8212, etc. I think he was the other. Like, it was a problem when I was working for the ISPs as well, like eBGP, default route propagation behavior, etc. This was a really real issue. And he basically stood up and then came up with an RFC, as far as I remember, 8212 and a couple other stuff, operational issues.
Now you see implementations on every vendor, right? Everybody implements.
Yeah, accept and...
besides Juniper that had implemented it when Junos was designed.
But there was no standard really. Some vendors accepting by default and then not sending, or some... there was no standard on that, and having standard is, at least for the operational issue, it will prevent some weird route leaks defined in the 7908 as well. Yeah.
I think we covered most of this, or this slide already in the discussion. This basically sort of summarized most of what we discussed. And yes, coming back to the comment Jeff made as well, in ASCONs, there's described a ASCON that describes indeed the relation, and there is a a policy object, a policy definition. That's basically the RPSL part, right? That describes, it sort of tries to use RPSL, which was meant as the routing policy language, to standardize that. And so you can, within or with ASCONs, you can also describe what policy, and indeed coming back to your question, what should happen if it's invalid or it is in the path or not. So that's the other part of ASCONs. So if you look at how it then sort of works, what it does, it builds basically a tree, right? So if you look at the right side, you see, for example, AS65534 semicolon customers that describes what ASs are behind AS65534, and that is AS XXX in this example. So then if you move to the left, you see that AS65531 includes in his ASCON AS65534, right? And if you then move to the left side, there you see that ASS65530 includes 65531's ASCON. So in this structure, you see how the cones relate, and so you can include either a ASCON in your ASCON or a AS number. And again, you would include an AS number if it's a stop AS, right, which doesn't have any downstream customers itself. And you include an ASCON if there's downstream ASs behind the ASCON's AS.
Okay, just a question.
Just some level of abstraction. You don't need to update whole chain when someone 2 or 3 cons away from you does some changes. You just trust whole object rather than
but for my understanding, what's happening here, like at the very left, 65530, when you say 531, customer 1, customer 2. Okay, what we are saying is 531 is 531 is my customer in my ASCON, as well as all whatever 531 has as a customer also. They are my ASCON. What about those customer 1, customer 2, just below the 530? What are those things? Customer 1, customer 2. Are you talking about 532, 533 as well, or?
Yeah. So you can describe a AS. Let's say an ASCON is a combination of the AS number and a description. So if you have customers. For example, in this case, AS65530 has an ASCON, which is called AS65530 semicolon customers.
Mm-hmm.
And in that ASCON, he refers to AS65531 ASCON. And he has ASCON customer 1 and 2.
So who are those? I mean, those are in this picture 65532 and 533, right? Sorry. So
it's a tree.
It's a tree. I mean, it's a tree. Now hierarchical tree. Maybe two level above. There might be 1,000 ASs.
Yeah, so what AS65530 did, it created several ASCONs, or it could create several ASCONs, which is AS65530 semicolon customers. That includes ASCON 65530 semicolon AS65531, which could refer to, so you can build a whole tree based on ASCONs. Right, and for example, if you're tier 1, you can create separate ASCONs per region for your customers and include those in your ASCON you're using. So it's basically AS sets.
Yeah.
Right? In an AS set, you can refer to another AS set, or you can include a ASN.
Yeah. So far, so good.
Good. So, yeah. So basically, the first bullet says it, right? So you basically use the concept of AS sets to describe the relations. It can be extended to declare exclusive upstream, so that's basically the other way around is what we have been talking about. The idea was to base it on RPSL, and again, leveraging the RPKI infrastructure as it is. Again, use as well the validators which we already have in place.
But here it doesn't say that verification, the acknowledgement should be done by the.
No, true. No. So if you look at the slide, I just copy pasted this from Tim. Thanks,
Okay.
Tim. But the slides are from April 10, 2018. So the acknowledgement section wasn't in back then. That's only recently been added. But as I
those two things
are
those two things are making this one trustable, in my opinion, and as well as more secure, like having RPKI environment, and also of course operationally simple, and already set, the infrastructure is there. So RPKI has been around for many years now, and yeah, adoption is increasing as well. People started to understand how it works, very easy. So I think leveraging RPKI for both of these proposal anyway, doing that. So we have good things happening here, guys.
Yeah, so
and comparison.
Coming then to the question. Yeah, there's the question. Yeah. So as I already said, right, the goal of what we want to achieve, AS path validation, is basically the same. However, the way to achieve it is a little bit different. And then coming back to what Jeff was saying, how to get things done within IETF, but maybe even more when it is a standard, how to get it done with vendors, is to make it as easy as possible to build, right? Because in the end, it's folks who have to write the code. And so I think having one solution instead of asking vendors to build code for two solutions makes it easier to adopt, especially because the goals are so close to the goals are the same. The way of doing it are so close to each other.
Agreed, definitely. Agreed. But there was one point which was made by Alexander. You don't need to wait from the operator to take an action, etc. Now we were discussing the priorities of the providers, right? Their priorities, not this, not that, etc. Even, I mean, we are talking 20% adoption on the RPKI side, although everyone is, you know, Mars, etc. I mean, everyone is saying, but anyway, adoption is still not quite good. The point is not running code on the ASCON side yet, but I think Alexander was saying he was testing, he tested for the Yandex network, because anyway, the ASPA is targeting for the end customer stop network side, so he tested that and it worked, etc. He was saying. So yeah.
Well, the thing is, getting better code to do something is not hard, right? It's you can get away with an easy hack to get something done. For example, I have another proposal in IETF which describes maximum prefix limits outbound. So define on the BGP session how many prefixes you want to announce. Building the code for that wasn't really hard. However, there's a lot of corner cases, right? So how do you handle different address families? How do you handle VPN routes? How do you handle more specifics? When do you count? Is it pre, post policy? Same as with the origin validation outbound draft, which is currently in IETF. The idea is quite interesting. So what you basically do is you perform origin validation on egress. So you sort of verify the routes you're advertising yourself. Sounds pretty easy. The thing, however, is that a lot of BGP implementations differ in the way where they, for example, strip out private ASMs. And you cannot perform origin validation against private ASM. So a lot of these ideas are sort of sound simple, are maybe not that hard to write the code, at least for testing purposes, but in production there are a huge number of corner cases. So building production code is quite hard, and especially because, of course, all the vendors need to take into account the corner cases, right? Because there's always a customer doing it a little bit different, or there's always one customer who did enable that one option. Again, I really think that as these drafts are so close to each other, that we should cooperate and make it easier to implement. Because in the end, we will have a running code earlier than when vendors have to build both of the RFCs, if it comes to RFC. And the issue is that you will end up with some vendors doing ASPA, some vendors doing ASCONs, and I don't think that's an ideal situation.
Yeah, definitely, I agree with you on that. Question, Jeff, maybe you can also have an idea on that. So if ASCON provider is defining that, and what we know is tier 1s, through their peering and direct customer relationship, they can reach to entire default free zone, tier 1s, right? So why not then ASCON is just done by the tier 1s, and then that's it. So 15 networks can provide entire default free zone security in this case. Let them do the whole operation once and create all the ASCONs, all the ASM belong to them, and then their customers, of course, and finish this PET validation problem. And ASCON by the tier 1s only, why not? It's solving the entire problem. RPKI already, of course, will be there anyway.
So you would need whole tree to work it properly, right?
Yes.
And
let them, those 15 guys, to do the operation, 14, 15, whatever.
What is their incentive to do so? Why would they do it?
But wait, what is
if
the...
You're a customer of a customer of a customer.
Either you will say, guys, let's wait years, thousands of networks to deploy to make it secure, and or you 15 will spend, maybe you will build a team and they will spend 3 months, 6 months, and then we will just guarantee the security of the internet. It is big amount of the security, let's say. Why not?
So we know all tier 1s by name. How many of them have implemented to the day proper security?
I mean, RPKI-wise, NTT came there, GTT, AT&T, they are coming.
We are talking 6 months and 30% of them, right?
But wait, then you are saying, in theory, Orhan, what you are saying can be done by them, if there would be enough incentive. Yeah?
Very theoretically. And right tooling, right people to implement it and whatnot. It's obviously incentive, but also being able to do this technology.
Sure. When ASCON is totally, corner cases, everything is addressed, then maybe pushing the tier 1s, making this, okay, if tier 1 just, comes into this game and then do this, we will solve the PET validation side. And then origin validation, anyway, adoption is increasing. Probably when they solve the PET validation issue, people can more push on the origin validation, and we can come to some stage. Just we should think, right?
Kubernetes distributes a lot of implementation and gives us ability to implement it as we go ahead, right? If you say there's 4 companies and they have to implement it and will solve world's hunger, it's not going to happen.
Very easy job. That's why I'm saying, easy, maybe not their priority. What is the incentive? Excellent question. Yes, but the incentive is this. They will be, they will have the power, and they will be able to say, okay, we made the internet secure. Like today we are discussing carrier neutral data center. So when the ISP gets the, one service provider gets the IXP environment, after a couple of years, we see that we are the center of the internet in this country. In Turkey, it's happened anyway. So, and same thing, let them say, we made the internet secure. And
I don't think so. Internet is distributed, and most people would want to keep it that way.
No, it will be still,
And
distributed for sure. But the security side of it, path validation side of it, may be belonging to tier ones.
It's the same issue as with BGP Sec. It sounds quite nice in theory, and in theory it works, but in practice it's pretty hard to get done. It would be the ideal world, right? If we if everyone creates ROAS, everyone, or at least all the tier ones and all the internet exchanges enable RPKI origin validation, and would do ASPA or ASCOs, then all problems are fixed, at least from the hijack problems. The thing is,
all are up to date and properly configured, and
exactly,
everybody thinks they're problem solved.
That's never going to happen, right? There's networks who won't deploy origin validation or ASPA or ASCOs because of business reasons. There's IRRs who take money from whoever and make objects for who pays, right? So unfortunately, or maybe fortunately, not a single entity is able to fix this problem. And that's maybe, as Jeff was saying, because of the distributed fashion of internet, and that's a good thing, and sometimes not handy, but in the end, I think it's a beauty as well.
Fine, but this is the idea. Maybe at the end we can come to this conclusion. People start to do it this way. Would be quicker, expecting, because from everyone to do this, many with the ASCON, with the many service provider in ASPA, even much larger amount of networks to do the operation. Yes, definitely BGP is distributed, and it will continue. The reachability side, at least, will continue. We discussed, by the way, this one was separate session with the Jeff and me. Should we change? Can we change? And will we change the BGP, replace with BGP with any other protocol? Like we had some candidates like Lisp, etc. We discussed. Definitely we know this shouldn't or will not happen, at least in foreseeable future. But this path validation idea, especially with ASCON, if properly would be managed. Anyway, we just discussed that one as well. At least we discussed. Maybe one idea. Practically, is it really that easy? And very first question of Jeff was very important also. What is the incentive? Okay, why they will do that? You should give them a really right incentive anyway. And my proposal was, okay, I am the leader of the internet. Okay, maybe this is the incentive if that works. By the way, it was really quite informative. What else we will discuss?
Let's see. Yeah. So as I mentioned, there is also a proposal in RIPE. This proposal has been proposed in other IRRs as well, which basically says or asks the IRR to create ROAS with AS0 for unallocated and unassigned other space. So basically, your router would end up with entries in your database saying that a specific prefix, which is not in this case assigned to a LIR by RIPE, that it has AS0. In other words, your router won't route AS0 simply, right? So basically, we're creating sort of negative, if you want to say, validation statements for unassigned and allocated space. However, when we filed this proposal in RIPE, we got quite a lot of feedback that folks didn't really like RIPE to sort of become part of, or that RIPE would start making routing decisions, because that basically is what RIPE would be doing then. So we are changing the proposal to, instead of asking RIPE to create ROAS, we're asking RIPE to create a Slurm file. And now the thing is, a Slurm file is, as you can see on the right side of the screen, it's a simplified local inset number resource management file that can be used with RPKI, or in short, to summarize, it's basically a file you can import in your validator with statements. So you can basically create, let's say, simplified your own ROAS, which you use locally on your validator. Or in other words, in the proposal, as we're changing it, we're asking RIPE to create a Slurm file for us containing statements for all unassigned or unallocated space with AS0.
Mm-hmm.
And then every network performing origin validation can now choose to use that Slurm file or not. So we sort of take away, if you want to say, a little bit of the power from RIPE, but we ask RIPE to do provide the information to do it ourselves.
And then based on the validator state, you can have a policy to reject, etc. again. Okay.
Yeah, exactly. Okay. So that's other work taking place. RIPE is now doing the impact assessment on this change proposal. I hope that they will finish that before the RIPE meeting in May. And so we will present it in the routing work group during the RIPE meeting as well. So if you like the idea, do support it in RIPE, please. And feel free, of course, to file it in other IRRs as well. And so I wanted to sort of quickly show a few statistics, because I like to end it with a positive note, instead of that we have to still do a lot of things. The good thing is that these numbers are sort of outdated already, because it's from September 2019, but that within a year we've seen an uptake from ASNs from 50 to 660 who are actually filtering or using RPKI origin validation, and so are filtering invalids. And the number of protected header space grew from 2/11s to 6/8s. That's a huge increase.
Yes.
And yesterday, Job posted this graph on Twitter, and it's really nice to see sort of the growth of ASNs and networks that are filtering RPKI invalids. So you can see there's a real.
What is this? What is this graph? IXPs, right? This one is IXPs rejecting invalids.
Yeah, it's IXPs, but also operators, right? So there's AT&T is named, but a lot of internet exchanges as well. Work Online was one of the larger networks. Then KPN, AT&T, Cloudflare, Wikipedia, now NTT as well. So yeah, I thought this is nice to see that actually the effort a lot of people are putting into routing security actually brings us somewhere. And so I made one slide. I don't know, do you share the slides with the viewers and listeners as well? Okay, then here you find some links to some general information, some deployment guides. There's a few links to the 3 most popular validators at the moment. There are more validators, and there are more coming, so that's good. Yeah, that's basically what I had to share from slides perspective.
No, it was really nice discussion, and ASCON is very now obvious for us, and we had a comparison between the different path validation techniques like BGP Sec, ASPA, ASCON. We discussed those and many other things actually. Almost 2 hours now. Let's end this session here. What would you say as a last couple words for the audience?
Yeah, so my advice, or I would want to do sort of do a call to action, right? So create your ROAS, start setting up validators. If you're unsure if you should reject intellits, then maybe not reject them yet. Do not lower the preference, but don't reject them yet. But first see what happens, which routes are marked invalid. And if you have any questions, if you have comments, if you want my help, feel free to email me. That's melchior@juniper.net. And again, as we said in the beginning, if you're interested in stuff I'm writing about, routing security, routing protocols, feel free to contact me on LinkedIn and follow me if you want to.
Okay.
But do deploy origin validation.
Okay. And also have a look at the path validation stuff and follow us on that. We will update. Jeff, for the
great work.
Yeah, great work.
I'm very very supportive for making BGP more secure, and yeah, I think Melchior is doing a great job. And try to educate yourself. It's not very obvious always why we do particular things. Read the drafts, read Melchior books. Again, I recommend it very much. It's really great reading and well written. Easy to read.
I will just say that. Thanks first, Jeff and Melchior. Basically, it was really good discussion. Hopefully, it will be very useful for many people to understand later on BGP security. Now, more than 4 hours video on the BGP security we have. You can have a look at, and you can always ask us the question on LinkedIn. All 3 of us we are using. Other couple things I want to say. If you like this video, please share it, comment it, and let us know what else you would want to hear from us, so we can come up with the other session. Probably 4 or 5 of us. We were just discussing at the beginning. We can get the Alexander and these 3 guys, and then probably you were saying Jap as well. So 4 or 5 guys, we can come up together also, and 5 of us discuss, open discussion. We can do this kind of things. Let us know which technologies from BGP security or in general BGP could be what you would want to hear. And a couple other things. Routing table podcast Melchior is doing. Please have a look at that one as well. I will myself check that one. Melchior and Rick is doing basically routing table podcast, and also routing security, BGP security. He has a book. Have a look at that one as well, please, because there is not much, especially when it comes to BGP security or inter-domain routing stuff. Only one book I knew so far. Bill Norton wrote one on the inter-domain routing sites, peering playbook. Probably you guys know already. And now for the security side, also Melchior has one. I will check. I recommend you as well. Have a check, and also I will publish it on the LinkedIn when I finish what it covers, why you should read it, etc., etc. It was a great discussion, guys. Again, thank you very much, and bye for now.
Thanks, everyone. Have a great weekend.
Thanks. Bye-bye. See you.
Bye.